I guess economic geology as a subject, as a discipline, split off from structural geology around the 1950s. Mm-hmm. Prior to that, structural geology was really big, you know. But for some reason, when geochemical analysis of rocks became cheap, geochemistry became the dominant force in economic geology, and people have forgotten about structural geology since the 1950s. Yeah. We need to bring that back, because structural geology is really the control of, you know, mineral deposits, like chemical alterations of rocks. But people don't look at it that way, and that doesn't make sense to me.
Today, I've had the pleasure of meeting with Jun Cowan here in the office. I've been talking to Jun Cowan for a long time, got some great ideas about how to map deposits, how to use structure in our interpretations, writes interesting papers and thought pieces. Really like his thinking. Today, I sat down with him. He's traveled to Dunedin to sit here in the studio, and we just start somewhere and keep going on a number of interesting topics. We kind of land on education again, sorry. It's that same sort of topic that we keep coming back to, but particularly coming out of the domaining and the resource estimation space. How do we build better domains? But yeah, how do we really bring in rocks into this? And Jun's got some fantastic ideas and has obviously been heavily involved in coming up with new ideas back in the early 2000s on giving us better tools. So he also steps us a little bit about through that history of how he got to where he was. So I hope there's something in it for everyone, but as usual, leave some comments there and let me know what you think. Anyway, enjoy. Thanks for coming in. I really look forward to this
I was in the neighbourhood, so, you know.
You're in the neighbourhood, Dunedin.
Yeah, Australia.
Well, it's a bit silly, actually, because as my wife pointed out, I was in Perth only last week, and you were in Perth last week. But
that's right.
Here we are.
Yeah, here we
are today. But thanks for coming into the studio. And look, I want to make a right introduction, but I think I'm going to turn it into a question. How would you introduce yourself? Because I usually say I'm a geologist and background academic, and this is what I've done in my career, but you've got this really kind of, you know, a little bit off the charts career pathway. So how would you introduce yourself?
Well, I'm a geologist. I trained originally in sedimentology. That's where I did my bachelor's at Macquarie.
Oh, yeah.
So my research was in basin analysis. And then I got a scholarship to study in Toronto for my master's, and that was for my fluvial sedimentology.
Okay.
So I did that in my fieldwork area was in New Mexico in the States. So it's fantastic.
That's fun.
Fantastic area.
Yeah.
And I got a bit bored with that because I find that once you sort of solve a problem, I just want to go on and solve something else rather than continuing on with the same thing. So I ended up I liked structural geology, always liked it. So I did a PhD in structural geology, and my field area was in Sudbury in Ontario.
Yeah. So obviously, then you're sitting there with a PhD. How does one roll into the industry from there on?
I was finishing my PhD and applied for a postdoc at UWA.
So you wanted to remain in research. That was the primary goal. Yeah.
So I sent out an application for an ARC-funded postdoctoral position.
Yeah.
And maybe this shouldn't be really taped, but I got a phone call in the middle of the night. He was a reviewer for that ARC proposal.
Yeah.
And said, really impressed with your application. Why don't you come and work for SRK?
Yeah, right. Okay.
Well, EHW at the time, they became SRK as soon as I joined. But
I can see.
But I said, I'll do my time as a postdoc, and then I joined SRK afterwards.
So straight from being an academic straight to a consultancy, I guess.
Yeah.
Right.
Because EHW was specializing in structural geology, applied structural geology.
Yeah.
So that's what I was interested in.
Yeah.
And although I didn't have any experience in it, I've done a lot of field work doing structural geology.
So what was your role was structural geologist and doing what exactly I mean, obviously we're going to get into this, right? That all this, everything is a structural problem when there's fluid flows related and so on. But was that immediately the connection into, was it a mapping sort of early exploration focused surface role, or anywhere problems needed to be solved in general, or?
It was mostly mine scale problems.
Right.
So, I wasn't really involved in the greenfield type of thing, and they weren't specializing in that at the time.
Right.
So most of it were problems associated with advanced exploration projects or near mine exploration. So that's where I came in. But I mean, I was sort of pushed into the deep end, and because I had no idea, but it was fairly straightforward, really.
Yeah. But I mean, that's fun because you see a lot of different deposits, right? At that straight away.
Yeah.
And you get that sort of framework of reference sort of thrown into your lap pretty quickly.
Yeah.
Yeah.
But I mean, it was interesting. When I joined, in the first week, I went around and introduced myself, and I said, wow, this interesting geological modelling. I've never heard of this before. And I said, what do you do? I said, well, I make these models for resource estimation. So I said, well, where did you do your geology degree? He wasn't a geologist, he was a surveyor.
Right.
Which was pretty standard, I guess, in South
Back
Africa.
In the day, that's where,
So I couldn't understand how a non-geologist would come up with a geology model. That didn't make any sense to me.
Right. So that's the seedling, I guess, for I mean, just as an analogy, coming into the industry, structural geologist, having some sort of, mapping rocks, fold structure, fluid flows, you get into the industry, which wasn't a pathway I'd ever been interested in. Because
really?
I studied in Amsterdam. I mean, I vaguely knew what pyrite was, I guess.
Yeah.
I mean, that's...
It's mostly petroleum, isn't it? If
it's
anyone was
all,
going to go
I guess, right? So a lot of my friends, they, do shell, or they do a lot of soil stuff and water stuff, lots of hydrogeology in Holland as well, but not something. We had one professor who was, I think he was from Poland, and he had a course that nobody really picked. So there were 3 or 4 people every year, and I remember picking it up and thinking, well, weird stuff. I mean, interesting, but this is still sort of floundering around. And only when I came to New Zealand, somebody actually offered me a job, and I thought, shit, you're gonna pay me to map stuff? Where do I sign for that? Minerals, whatever. If I can map stuff, the rest is secondary. Not understanding the industry at all. Right. So I'm listening to you, coming into a PhD, probably very geology and academic and research focus, and then suddenly consultancy rings you up. It must have been a bit of an awakening as to how, what they want from you. Right, and then how people do stuff. So the same, I come in the industry and said, "Is that how you're doing it?" Interesting. I mean, not that I'm to say or smart enough to say you're doing it wrong, but certainly to say, well, that's an interesting approach.
Yeah, I mean, I was completely ignorant at the time.
Yeah,
but I heard rumors about EHW back when I was a student, when I was a PhD student in Toronto.
Yeah.
So everyone was, a couple of people actually were hired by Etheridge Henley Williams.
Yeah.
And, I heard that they were doing really good work. So, okay, well, then that's a transferable skill, right?
Yeah.
So.
But at that point in time, and sorry if I probe too deeply, just let me know. But I'm really interested in, so how old were you at that point?
Oh, crikey.
Ish,
Mid-30s, I guess.
Mid-30s. So with
something like that.
Clearly some life experience. You travelled, right? So
not really. I was a full-time student, basically.
Yeah, right.
Yeah, I travelled, but I just travelled on scholarship, so I didn't really do any real work.
Yeah.
EHW was my real work. That was the first job that I got. Well, other than my postdoc, which is really another level of research, right? So, other than my postdoc, EHW was my first job.
Yeah, okay. But so then you come into, obviously, the world's largest geo-consultancy, right? And
at the time, they weren't.
No, at the time,
that's
probably
small.
true, but they're probably still quite small, but not the smallest for sure.
No,
definitely
they were in the
bunch
top
of
5 or whatever.
Definitely a bunch of people who have built a name for themselves. So, you come in there not knowing how this industry clicks and how it works. How long did it take you to develop ideas that you felt were either new, or how could you come along into a consultancy? Because, you know, I haven't run a consultancy myself. This is how we do things. A new person comes in. Yeah, there is freedom to express yourself, but you must have had a few points where you thought, okay, well, you just described one. Okay, hey, there's a surveyor doing resource estimate. That's interesting.
Yeah, that's,
well, you know,
that was number one.
Right.
Number two was when I realized that these models that were digitized by hand in section, right, they didn't actually look anything like structural sort of controlled deposits. I mean, and, you know, at the time we didn't have a real way of actually sort of viewing deposits easily.
Mm-hmm.
But the shapes that were drawn weren't, well, they didn't make a lot of sense to me. Well, for example, one of the first jobs that I had was coming up with domain volumes for Telfer.
Yeah.
And Telfer, everyone knows that it's an anticlinal fold sort of scenario. So you have, in that situation, you have three domains, one for each, two for each of the limbs, and one for the fold closure. And I didn't understand why that had to be done that way.
Yeah.
It just didn't make any sense because the whole thing is continuous.
Yeah.
It's not as if it's a chevron fold or anything like that. So, yeah, these things these questions accumulated over a month, you know, like it was a matter of a month that I noticed that people were doing weird stuff that...
So what's the feedback? Because you're sitting with far more experienced people in the industry around you who've been doing this for years. Is it the classic sort of little cartoon that you have with the guy with the square wheel and said, you know, no, we've always done it this way? I mean, what at that point?
Yeah, a bit like that, yeah.
Right.
Yeah. Like I didn't understand the concept of simulation when a geostatistician explained to me. Mm-hmm. We were working on trying to predict where the clay pods were in what do they call it? Ion channel deposits. Right. Because they cause a problem, right? Yeah. Waste material. So he was going to geostatistically simulate these things. It didn't make sense to me because, I mean, these are overbank deposits and they occur in a certain pattern, you know, geological pattern. Mm. And since I studied fluvial sedimentology, I knew how that worked. And also the faults were actually sort of controlling their positions as well. So there were two things that could be considered, but they don't go in the simulation.
It was straight numerical.
Yeah, it's a straight numerical method. Yeah. So that didn't make any sense to me.
Yeah.
No geological input into the simulation process.
Yeah. So that became a bit of a theme then quite earlier on, I guess.
Yeah, the divorce between, you know, structural issues with geostatistical estimation methods, the fact that those two things weren't done together at the same time didn't make any sense to me.
Yeah, and look, and I've obviously talked about this subject only recently, and we had just at all conference basically, not devoted to it, but where this subject came up numerous times, and we all know that, you know, as I joked at the opening of the conference, you know, that there's two circles and they're not really overlapping. The geostatisticians do one thing really well, and the geologist should do one thing really well, and then but both are important. You can still obviously do a lot of things wrong on this side as much as this side. What the balance is to be debated, and maybe we'll get to that. But you know, at risk of saying, yeah, look, geology is important, I really want to try and understand from your thinking, having basically devoted your career to this, right? Because then obviously you get to the Leapfrog days, and maybe we'll come to that in a second. But other than to sit here and poo-poo geologists not doing enough geology and resource models, because that message is obviously old and stale, even though perhaps we are not shouting it too loudly. I want to really try and understand where it comes from and what we need to do, because we all seem to say the same thing, right? Geology is important, and this echo chamber that some people call out, you know, LinkedIn and so on, to be, where does it then go wrong? I mean, if people in a consultancy that arguably employ lots of experience and smart people can't see that between quotation marks, how do we possibly get out of this? And was that then perhaps the reason why after a few years or months in such an environment you said, shit, I can't do this. I need to do my own thing here. You know, how do we really get out of that? Geology isn't honored enough, sort of.
I guess you just invent new ways of doing it.
And that's where you're sort of foray
because
into...
I mean the way geological modelling was done in sections didn't make any sense to me, because because you need to actually take sections in the appropriate orientation, and vertical sections aren't normally, unless the fold axes are horizontal.
And at that point in time, because, and again, I want to get to this paper that you just put out on this subject. At that point in time, were sections at all orientated with some thinking, or was it, because I mean...
Very few people were using, like, I think, I can count on one hand.
Because the classic approach was that you created a local grid that was rotated to match the geometry of the ore deposit, and then when you do take the section, arguably it's not particularly perpendicular, but it's close enough to it.
Could be,
right?
but that's just one axis, right? It's
Sure.
rotated about the Z, and most deposits are plunging.
Yeah.
In some degree or another. So, I think it was more of an engineering solution to have a rotated grid like that.
Yeah.
But it's not optimized for geological interpretation.
But even at university, you would have learned to create sections across, in various angles to understand. I mean, we didn't have 3D models when we studied structural geology at university, right? So you had to make sections, and I mean, I would still be hesitant to remove the section making process from the geologist toolkit in a mine, because the thinking that you force people to go through when making a section is valuable. You just need to watch out for the sectional bias component of it, right? I mean, not everybody can sit there with their own version of Leapfrog or the core logging geologist and do everything in 3D. That's just not practical.
Yeah.
So
I haven't used the section in years. Like, to be honest, I haven't.
Neither do I. I mean, but we have the luxury of using whatever 3D modeling software we use and turning it into whatever angle we want for it to work for us. So
to me, it just didn't make any sense. I mean, every object that you are modeling, every lithology, has its own axial orientation. So, in our paper, we only discuss one very simple scenario, one axial orientation. But when you're dealing with several lithologies, every lithology has its own orientation. You need to figure that out.
Yeah.
We didn't really discuss it in the paper, but you need to go through that process. And, I've seen situations where geological modeling is done through some mathematical method. Well-known geostatistician that contacted me through LinkedIn, and he wanted to test out his lithological modeling routine. And he asked me for a data set, as XYZ lithology. And I told him, you can't model lithology like that. It's just impossible. You need to use you need to do distances from contacts in order to model geology, and you need to have a hierarchy of age, a chronology of age. But he was completely convinced that he can model geology using that type of data set. And he wrote, he's written a textbook, and it's really quite well known textbook. So there's a disconnect. There's a complete disconnect between some geostatisticians and what should be done in geology.
Yeah, well, look, I can see, and again, I've covered this a couple of times as well. I mean, the software packages out there, they are certainly moving to this I think I've only just learned this term during the conference, which is one of the reasons we have conference, I guess, to listen to other people's ideas. But auto-domaining is the term that, I don't know whether that's a button in a piece of software yet, but, you can see that's ultimately where software companies will drive it. The more they can automate stuff, I think the more you can probably make it accessible to everybody out there.
Yeah.
And one thing that I'll have to say, I did give one particular group a data set thinking, good luck with that one. And they came back within 2 hours with a model that actually quite surprised me. Now, I don't know.
What was it? What was the input data?
The input data was just lithology and some basic structures, and with some information on age and
Relative age.
Yeah, relative age. Although that wasn't as much of an issue there. I mean, it wasn't hugely complex, but it was at least geometrically complex that I had to do this by hand to get out of the model what I needed.
Right.
And so I was quite astounded to see within 2 hours. So I can, with some imagination, I can see that if the input data would be on it for the chronological context and the relationships and some structural controls and various components, if that would be possible, again, this is way above my pay grade, I can see how at least inferences can be made that then are helpful to the geologist. It probably is far away from models that we would then lock in to actually use in estimation or so on.
Yeah.
But I can see for that deposit, if I would have had that ability, it would have saved me 6 weeks of looking at this and spinning it around and figuring out. So I'm not discouraging that development. It's just that it's going its own pace.
I mean, it'll be done. Like I can see a way forward.
Yeah.
But it needs to be done in the right way.
Yeah.
And not all software companies or people who work in that space really know the details of structural, geometries that you need to.
I think that's where, sorry to interrupt, but I think, for some of these companies, I know some of the people that work in roles to honor exactly that, right?
Yeah.
And I respect those people enough to know that they're trying to probably fight that. I mean, I can imagine a meeting table with all the software designers and the managers and this and that, and there's two people who are there in the roles that we would play to put that on the table and to make sure that that's an ingredient that goes into the mix, right? To make sure that people actually get a tool and a product that is geologically, responsible to use. So, I mean, I can only imagine because I never worked for a software company. I probably never will, but. We need the software to do what we need to do, but it's the usual conundrum of it being misused, then we can get some terrible results. But maybe before we dive into that too far, I want to go back to the timeline a little bit about how you got into that Leapfrog, because so to pick it up, you got out of that academic field, you join SRK, a whole new world opens, you see, guys and girls, this isn't the right way to do this. How did that then permutate in this Leapfrog idea, if I call it that? When did that happen, and how did you sort of? And I'm asking you this because I really enjoy the innovation part of these discussions as well. I mean, I find you a trailblazer in many ways, and as much as we might disagree on a number of things and how people throw shit at each other on social media all day, without people like yourself, we're not moving. And I fundamentally think that needs to be appreciated more by people, right? So I'm really interested in how that process worked. I mean, was it an epiphany? I mean, where you're sitting in front of the traffic light? I mean, describe that process.
I was familiar with interpolation because I did part of my thesis, my PhD, interpolating structural data. So I gathered a lot of structural data in the field, but I didn't want to just plot them. I wanted to sort of, generalize, form trajectory maps and things like that. In order to do that, you have to write code to do that. So I discovered a method of doing, a clever method that was put out by a guy called Hardy. Roland Hardy, I think it was, 1971, I think it was, paper. And I studied that. And so I had a bit of background in interpolation, and I knew exactly what type of interpolation method that was really quite effective.
Mm-hmm.
But I also knew that the limitation of it was you couldn't use on a lot of data. So I'm not a coder myself, but I bribed a geophysicist to code it for me while I was doing my PhD. And I could only use 89 data points or something like that. It was something ridiculously small.
Mm-hmm.
So when I went to SRK and noticed that what people were doing, they were sort of drawing loops around high grade, to domain it out. And I said, that's what you're doing is contouring in section.
Yeah, yeah.
So what you need to really do, why don't you do this in 3D? And they said, what do you mean? This is how we do it, So who else does this sort of loop drawing thing? Well, every geologist in the world does
I love it. Yeah, we still do a lot of loop drawing out there. Yeah.
And I said that's just crazy. You should figure out a way to. So I basically, at the time, I think it was year 2000 or something like that, when Google just came out.
Yeah.
And it was actually John Van that was saying to everyone, you should use this Google thing.
Yeah, right.
Google, right?
Yeah.
So I said, okay, well, I'll just type it in. So I just typed something like multi-quadratic interpolation, 3D or something like that. And then several companies came up, and Iran's in New Zealand was one of them. And it was the only company that could actually do, thousands of data points. So I thought, wow, that's it.
Yeah.
So
that's amazing.
I contacted them, left a phone message, and because they had a little sort of DOS sort of thing that you could play around with, it was just on their website, not being really applied in a big way. So yeah, I contacted them, left a phone. I was really excited because I knew that was going to be the answer.
Mm-hmm.
So I phoned them, left them a message, and they didn't return my call. And yeah, I still have the initial contact email.
Yeah,
about that. It's quite interesting.
Yeah.
Because they had, the idea didn't come from New Zealand, and there aren't too many, sorry about this, but there aren't too many geological firms in New Zealand, you know what I mean?
Yeah.
So
there's one great one.
That's right, yeah. But so I came to work with them, and these guys were just, they're like sort of characters from the Lord of the Rings, they're sort of in the basement eating pizzas and drinking,
cold coffee,
Coca-Cola and coding like mad.
Yeah, right, yeah.
And there were only like main people, about 5 people or something like that.
Wow, yeah, early days.
Yeah.
Yeah. So then
And then what I did was I taught them the basics of, the basics as in the basics things that were I think were important in the process.
Mm.
So there are a lot of basic things in geology that are not relevant, so I didn't teach them those things.
Mm.
And I made sure that they didn't talk to other geologists, because I knew that as soon as they do that, they'll be derailed into a different direction.
Yeah.
Because I knew that what was being done was not the right path.
Yeah. Interesting. Yeah. Because obviously, 22 years later, this is the key tool that every other software has picked up as well, and
well, at least the interpolation bit. Yeah.
The interpolation bit, yeah. So, and I said just jokingly, we're still stringing shit together in a little loop and gluing things together, and I think the numbers that I keep lose track of still indicate that's close around the 50% mark. Does that surprise you at all, that 50% of the industry is still drawing loops on sections?
No, not really, because the Leapfrog, when it first came out, by the way, the Leapfrog right now is different. That's not the one that I helped to design.
Yeah.
But when the first version of Leapfrog came out, the people who took it up were exploration geologists. Because exploration geologists are very flexible people.
Right.
They lose their jobs every 2 years or whatever, you know.
Yeah.
And they're very used to picking up new tools, advanced tools. So that's where it went in, really. It was really difficult to get into the mining space because they are very conservative. They just want, like a press button process, you know.
Is part of the problem that if you're dealing with a fairly sizable open pit with a gazillion grade control holes that in 2002 on your 486 computer, that's going to take 20 days
yeah,
to
run
interpolate.
it would have taken a long time. Even now, it takes a long time. But we weren't so much focusing on grade control at the time. We were just looking at exploration data. Yeah.
But it certainly changed the way we interpret things, right? Because I compare the process of doing what I do as a resource geologist in Leapfrog or another software. Again, I don't want to, make this all about one company, but I interpret it like the same process of making a map. When we went to university, I'm interpreting a framework, but I'm doing it in 3 dimensions.
Yeah.
Right.
Yeah.
I mean, the process, how I get there, I still have in my mind what it needs to look like in 3D. And however I get there, whatever buttons I need to click, whatever settings they do to get me to that result that looks good, I don't care how I get there necessarily. The more functionality that software has, and the faster it is to give me what I need as the end user. But maybe, again, so having made that discovery, I guess, for lack of a better, or that innovation, and added that to the industry. Maybe fast forward to this paper that you just put out, and I'll put the link in the description for people, and I'm sure they've seen it already, but why did you feel the need to write that paper right now? I know from talking to you before that it's been some years in the making, right? And it was Ron Reed and yourself, obviously, Ron Poodle.
Yeah.
So why now, and what are you hoping to achieve with it? What was it?
The main reason for that is, the whole purpose of coming up with the Leapfrog concept was to make the resource estimation process faster and more accurate.
Mm-hmm.
Now, one of those things has happened, which is the speed, right? The accuracy part of it is actually gone downhill. It's not. We see some horrendous models, and to think that using Leapfrog will produce an accurate model is a complete myth. And the reason is that it's probably a lot to do with the way it's taught. I had a fairly straight idea of when I taught Leapfrog, more than 10 years ago now, it wasn't a software operation tutorial.
Mm-hmm.
It was a structural analysis tutorial.
Yeah.
So I taught basics of structural geology to people, and they can relate the structural geometries and fabrics that you see in the grade, and apply what they've learned. This is a fold, or this is a thrust fault that's propagating from the limb, and that sort of thing. So I didn't, it wasn't concentrating on the software itself. The software itself was really simple to use. And it was basically a tool. It's like a hammer, right? Use your hammer to actually analyze geology or handlands. It was just like that.
Yeah, but and I've asked this question before, and I can't remember of whom, but who carries the responsibility then to teach this stuff? Because I could argue that it's not the universities, because they don't understand what it's used for, right?
No.
We've just seen it with the Parker Challenge. We can look at the metadata for those who submitted the models.
Yeah.
And the academic submitters are not quite getting the application of the model.
They don't
So
they're nowhere near it.
No, they're nowhere near it. Well,
Yeah.
that's one way to put it.
Yeah,
I'm being strategic with my words here.
No,
but,
I totally understand.
So,
that, yeah.
so we can't expect that from them.
No.
A person comes in the industry. I feel the employer obviously has some responsibility to look after professional development of their staff, but I also know the practicalities around that. I mean, again, there's this great paper. I think Scott sent it to me the other day, and I still forget the bloody authors there who demonstrated that. And I'm paraphrasing probably incorrectly. Was it for the super pit or some mine in Kalgoorlie when in a downturn they laid off geologists, the actual efficiencies went down, and you could actually quantify that, right?
Right.
And I guess the point that I'm making that companies run by the engineers, and this is no slight on the engineers and accountants and so on, probably don't fully understand what we do, don't build enough geologists in the budget, probably ultimately end up replacing them with some AI thing, which I kind of, like posting about as well, to stir the pot. But so what I'm saying is I can sort of understand that if you don't hire enough geologists, and then those geologists are immediately so overworked that they can't find another week just to do a course of some sort, right? I mean, I run into this all the time. People want me to come and run courses, and I said, look, I can do, what we really should do is a 5-day course. So I can take my time with people, really look at the domaining, and so I don't have time for that. Some people do, and I love it because they get how important some of that. 3 days because people, production and pressures and so on.
Yeah.
So all I'm saying is that it sounds good to put the responsibility on the employer, but with the margins and so on, I can kind of see that that's not easy.
No.
And then is it the consultants? Well, they charge $1 million to run training courses, and then they focus on the geostatistics more than the domaining.
Yeah.
So. And then if it's not the software companies who should take the responsibility, because
to be perfectly honest, it should be the software companies.
Is it though? I
think so, because the software companies are largely making software that they can sell. Like
but that's
pancakes.
their job, right?
It's their job, but it's their job to actually teach everyone how to use it properly, right?
Is it though? So. I mean, if you build a car, I mean, I'm not teaching you how to drive. I mean, here's a bloody car. If you kill yourself, it's not my problem, right? I mean, I need to build airbags in the thing, but
yeah. The way I had envisioned was actually there were two parts to it. There was the software and there was the education component to it, and the education component never went off the ground because I was told that I was the only one teaching it that way.
Well, so this is interesting because I think if I align that with my view, I think there's actually a massive value proposition in teaching it properly.
Oh, absolutely.
And I think software companies are missing that value proposition.
Oh,
there.
Yeah.
And I think I got close with one company working together with them, and for some reason it's not progressed as much, and it's gone back into teaching people how to click. Well, clicking the buttons degrades it a little bit, but essentially use the software to produce stuff rather than the actual fundamental framework of how to build stuff and why and those kind of questions. But I think if you teach that, then you're associating your brand with how to do it properly so that we can get out of this freaking
absolutely.
Vortex that but so I don't think it's their responsibility. I think it's much more a missed opportunity of anything.
It is a missed opportunity. It is. And the design of the software, well, at least Leapfrog Geo, is just wrong type of application.
And I know we want to be careful here, but I'm interested in that because I use that software regularly, and I have my love list of things that I'd like to see, because there was a change at some point between software versions, and I can't remember it was probably slightly before I started using it. What went away that you felt shouldn't have gone away then? I mean, or should be in there?
Well, there's a lot of workflow framework in the software, which I don't like. Because in we know geology, right? As geologists, you know that you drill one hole, you have one story. You drill another hole, you have a completely different story. That just keeps on going. So putting a framework as a workflow framework into software doesn't make any sense to me. Like, doesn't make any sense.
Can you drill down on that? Because I want to agree, but I can see it's a double-edged sword, because you need... What I quite like about the workflow, and I make a point in my course on this, that I have a slide that says workflow is not recipe, right? I mean, it's not a recipe, but a workflow is a logical way to think about, and I call this an iterative process of modeling things, right? There's a workflow that is attached with it. It doesn't mean that you copy and paste the same thing across the board, but I think it does allow a very organized handling of your data. And so, sorry, I might need to go one level down on that.
Yeah, but that's a bit different, though.
Yeah, I know it is, but I'm just trying to say that makes me understand why it is the way it is. Because back in the days, I mean, when I was still using Serpac, if you have a sizable deposit and you want to run some sensitivity tests, right, you end up with all these text files with all different scripts in there with names that you have to then fix. And if you change a name here, then everything falls over. And the amount of time that you spend trying to troubleshoot some trailing space that you didn't delete or something like that, that all went away. And I think part of the reason that went away is this workflow. But it's a double-edged sword, and we discussed it at the conference as well. People were poo-pooing the fact that some of the resources that were submitted, it was obvious what software they used, and they got stuck in the trap of going from workflow to recipe. Yeah, and I think that's what you're talking about.
Yeah, that's what I'm really referring
and so
to.
I'm a little bit specific about the language.
Well, for example, the Leapfrog Geo wasn't called Leapfrog Geo in the beginning. It was Leapfrog Hydro.
Right.
So it was specifically built to deal with hydrogeology. Mm-hmm. There's a bit of a complication with the history, but what we were building through SIK was completely different, because it was for the mining application, and I knew that the hydro thing, it just won't work.
Right.
So that's how it ended up with the stratigraphy being, one of the highlights or the main framework of the software. Now, I've looked at hundreds of deposits, and I think there was one case where I was asked to build the stratigraphy model, and only because the client told me to build it. Otherwise, I would have done it a different way. Mm-hmm. So the main attraction of the software that is currently out there isn't actually relevant for mining at all.
I never used the stratigraphy tool at all.
Exactly. It should never be a highlight. Also, the way the geological models are subdivided according to faults, that's a huge problem, because you might define a fault here, but then it will disappear in another area. Yeah. So you need to actually handle faults in a different way.
How then? Because I can't see how you would otherwise use that from a software perspective. How would you deal with that? You have to at some point draw a line somewhere. This comes back to my original map that I created as a student. You draw a fault because you see something offset. Shit, where does it need to go? I'll put some dotted lines there and it looks great on a paper map.
Or it could terminate.
Yeah, or it could terminate.
And you can't terminate anything using an IBF. So,
no, exactly.
That's not built into the software. Yeah.
Yeah, but I can't see how that would be done.
Another thing that has completely changed is all the details are actually hidden, like the controls behind, lithological modeling, which you could actually sort of open and understand. I think that's
an example, because
distance values. Can you get distance values?
Distance values. What's
from? You create distance values down the drill holes.
Yeah. And
that actually controls. That is the data that you're interpolating to create.
The distance to something down a drill hole.
Distance from a contact, yeah. So you have lithology A and B, where the contact is 0.
You can do that.
You can see that.
Yeah. Well, you'd have to do one thing. You'd have to evaluate whatever it is that you created onto the drill holes, and then you have that point, and you actually can do a simple formula to get the depth. So that's doable. Yeah.
Right.
Yeah. I mean, you have the workflow for that instead of a readily available number, I guess. But I can think pretend to be a software person and say, yeah, the software needs to be told that that is a contact that you're interested in for it to be flagged. So you need to back flag it to the drill database, and it just becomes down the whole depth with a column with a field that says 2, and that's your.
Yeah, that sounds really complicated.
It's not complicated.
It was really quite. But the way it was done originally, it was is incredibly simple.
Yeah, look, and this comes down. I mean, and I did talk to a few people who are in the software world about this off and on camera. I mean, I can also imagine, you build a piece of software and then you put it out and people are going to fucking break it. They're going to try and push it in areas where it was never intended to work. And
maybe that's why they hide a lot of things, behind the scenes. But I don't think it's a really smart idea.
Yeah.
Because in mining, it's not like you're using it, like an iPhone.
No.
You don't want iPhones to be broken, so you hide everything underneath. But for mining,
Yeah. Look, I mean, we might be getting stuck in a rabbit hole here, but I can imagine that it isn't easy as a software developer. You've got a list with 1,000 requests on it that everybody wants. Some are more important than others. You've got bigger clients, smaller clients. There has to be an incredibly complex architectural problem that all of these companies have to solve. I mean, and I usually use Sterk as my example. The architecture was built, in the late 80s? And they're still using that because you can't, once you add little layers to it 30 years later, good luck with completely revamping it. So I can also see that as you develop a software, once you're committed to bolting one piece on and another piece on that overlaps that piece and that piece, that you can't just unpeel that. And again, I'm not a coder writer. I used to do a little bit in younger days, but I can sort of understand that if somebody says, can you just code that? And I should call myself out because I said exactly this the other day on LinkedIn. It's like, fuck, how hard can it be, man? It's 2 lines of coding. But there's always more to it than that.
Yeah.
So I don't want to necessarily play the defending game, but I want to try and challenge my own thinking here as well. Yeah, it should be easy to get this depth thing. But yeah, something needs to be flagged, and that has to be an action that is user-driven, right? So
another thing that really I thought went backwards was it's a wireframe-centric program. Yeah, you're always dealing with wireframes. So your geological model is a wireframe.
Yeah.
Whereas in the past, we dealt with interpolants. So interpolant is a saved equation on your computer. So you might have your gold interpolant, you might have your lithology interpolant, and you have several lithologies. You have all of them saved. And you just work with the interpolants. You don't actually wireframe anything until you want to. Right?
But how do you validate then what you've built makes sense?
You just create the wireframe, or you can create a block model. It doesn't really matter. It actually gives you more flexibility in the way you build models.
Okay.
For example, I did a training course involving there's a porphyry sort of data set that I used. And I got the class to interpret their own trends. You can just draw it, like freehand draw these trends off this data. So you have 10 geologists drawing their own interpretation. So, I said, give me we're going to combine all of those interpolants and we'll take the average. Mm-hmm. So this is exactly your Parker challenge.
Yeah.
It's, you have the variation saved in each of the interpolants, but you basically come to an average by just taking the average, which was fantastic.
Yeah.
You can't do that now.
No, but so how does that relate to the capability of software? I mean,
well, it's so much quicker to do something. It doesn't require you to stick to a particular workflow. It was clever in the way it was designed first. Yeah,
well, I think maybe just branching off on that last comment. I mean, that is something that I explored a bit as well here, because we are required by our codes that govern us to talk about potential other interpretations, right? That's a JORC requirement.
Yeah.
I'm sure you know it well. And I find it interesting is the great word to use here to see what people put in that. And I think by and large, the comments 99 out of 100 is, we've looked at different interpretations, but they won't infect the final tonnage and grade very much, right? And there's always a variant of that. But then you actually look at the very outcome of the Parker Challenge and the things that you're talking about, and it's actually fascinating because you're so biased, right, at cognitive bias that you get stuck in. Yeah, if you get one person clicking a different button in your favorite implicit modeling tool, that's not really testing your theory. So we need another way to condense that known variance in interpretation into the software, because the software is not going to do it for us. That's basically what I'm saying.
No.
I'm not sure how we ever get out of that one.
Oh no, you can set up. You can get the software to analyze the data and then set up your default values according to what you've analyzed. You could do that. That can be done.
Yeah.
But unless you know what you're doing, you wouldn't be able to do it.
Yeah. Well, that's
that requires geological knowledge. You see. So that's why you can't really separate geological interpretation process from software development, you know.
Yeah. I want to jump back to the responsibility because we drifted on from that. So if I can come back to it with a summary along the lines of, it's not the universities. It's probably, it should be the companies. Arguably the software providers should play a role in it, but I don't think the major responsibility lies on them. To be honest, my view is that it's the person themselves. That's where I feel the responsibility should lie.
Yes, but the person needs to be educated.
Yeah.
And there's no, I mean, where's the education right now?
Well, papers put out by various people, videos. There's a lot of information out there.
A lot of information, but how much of that is really useful though? For example, we were discussing the domaining process, right?
Yeah.
There's not a lot of literature on the domaining side or geological modeling even. That's the important step first.
Yeah.
And then you come to the domaining. That's really not discussed. Even though people say that's really important, it's not discussed though.
No, look, you come into the industry with your personal thoughts and not to say that you think that you're so naive that you think everybody thinks the same way, but I've learned by starting RSC and hiring people that not everybody goes to bed with a paper on Friday night, because we're not all sad fuckers like René sometimes is, right? Yeah. So, and I can't expect that from people either, right? At the same token, I do want to work with people who are dedicated to their craft and who enjoy doing what they're doing and learning stuff. So I have some expectation, but I can't expect people after a 45-hour week, if they had a long week with us, to grab a book off the shelf and study domaining, right? So I'm trying to come to grips with a balance there, because I do think there is some responsibility that people have in every job to say, okay, I've gone to university, I've got that degree, but I don't stop learning. And that's what I enjoy, people, giving feedback on this podcast as well, because those are usually the people that subscribe to that and listen to that and want to learn about other people and other ideas, and the whole reason I'm doing this. But that's where I come to my point, that I think the responsibility is mostly there. People should take that responsibility. I mean, it's not hard to find. You can YouTube yourself and find a horse with 5 legs giving birth to a zebra with 5 eyes, right? If you want to find that video.
Yeah.
So you can find videos.
You can find videos that's irrelevant.
Yeah. Well, no, but you got stuff out there. If you Google that stuff, you will find your stuff. You will find a paper that I read. You will find people who...
Look, I mean, I write stuff, but I don't get into the details too much.
Right.
Because I just don't have... It's not in the right format anyway. But I try and sort of write in a way to get people thinking, and that leads to wanting to know more. And I think the answer to all of this is really education. I mean, to be honest, that's the only way. And you can say that people can be responsible for themselves, but the information, to me, is not out there because I haven't written it.
Yeah.
And so I'm actually on the path of educating people. That's my main interest, actually.
Right. That's interesting, because we tend to naturally gravitate, whatever discussion I'm having, I could be having discussion about unicorns living on Mars, and we would gravitate towards education. So this is probably the moment where people switch it off and go, oh, here we go again. But it is where it all gravitates towards, right?
It has to be, yeah.
If we're solving problems,
It's-
then it has to be by making it known to a wider audience, and that's an education problem. So, what's in the pipeline for you then to address that? What are you working on? I mean, you've just written this paper. Is that part of a bigger process? What drives you right now? What drives the next 20 years of what you do?
Well, I'm developing a type of education program at the moment. Yeah.
Yeah. And you want to, I mean, without divulging ideas, because I know, you know, that's obviously sensitive, but, you know, global audience.
For a global audience, hopefully.
Yeah. Well, look.
So it is a bit like what Nick Tate's doing on YouTube, but it's not the same as what Nick Tate's doing.
Well, not the same content.
It's certainly not the same content, but the mode of education is different as well. So there's a lot of education in geology has gone downhill, really.
Yeah,
over the last, since I started studying geology in the 80s.
Yeah.
And those things are not getting replaced by new people. So younger people aren't being educated at the same level as you and I, you know. So that needs to be really the basics needs to be really taught. And it has to be taught in a engageable way, you know. It has to be.
So here's my fear, because again, this is a particular point that we've really drilled down on a fair bit, and I do, and for your interest, not particularly for people who've listened to me talk about this a lot, the AusMM is into this space a lot to try and do their bit in education, but there's obviously, you know, there's a financial component to that as well that I think is a hurdle for people. You can't reach the masses if you charge $3,500 to somebody sitting, you know, in Turkey for a course. It's not going to happen. I mean, maybe you reach out to 10, 20 people, but you're not going to...
No, you're not going to reach the masses.
You're
the
not
masses
going to reach
will,
the masses.
you know...
So Nick Tate does his stuff on YouTube, and I think it's fantastic. I mean, you can tell from the comments how much value people get out of it.
Yeah.
And not necessarily and they are there too, but not just the 20-year experienced geologist working for a mining company, but the graduate geologist in Ghana who has got as much access to YouTube as we do here.
Yeah.
And they are lapping it up.
Yeah, absolutely.
And I mentioned this at the conference because there's a guy called Michael Pearkes, and I don't know if I pronounce his name correctly, and he's super active on Twitter, where you and I play a bit as well, but probably to a lesser audience, right?
Yeah.
But he puts all his geostatistical teaching content out for free. And I've watched some of it. Now, it's way over the top of my head as a dumb geologist, but man, it's all there. And it's done by somebody, in my view, who really understands what they're talking about. Now, when I mentioned it at the conference, I got shot down by a very old school professor from Southern Europe who was
was he familiar with the content? Or?
He was familiar with the content, but I think sees jobs being compromised by this all being out for free, right? Because... Well, I'm guessing as to his arguments, but a few things clicked for me. And now listening to you speak about, I mean, Nick Tate, I mean, there's other people put free stuff out there. You're putting stuff out there. To me, I don't think institutes like the AusMM may necessarily win that battle in the education space. I think it's literally putting stuff out for free. And then, yes, you still have the problem that you need to find the right content. Right, because that's what you said.
Absolutely, yeah.
But the right content will drift to the top. There is a natural algorithm through all of that. I mean, Nick Tate stuff, if he wouldn't know what he's talking about, he wouldn't have a master following that he has, right?
Yeah.
I think that's where this stuff is going. And people that ring me up or send me emails from Bloody Sweden, driving to the mine, listening to this podcast, they are the ones looking for this.
Yeah,
and I think that's where you get your audience, and where is the whole reason I'm doing this, to get people familiar with people like yourself, so next time they know where to Google, to go back to John Van's.
True.
Don't you think? I mean, that's where education might go, and how do you monetize that? Because I mean, not that you're
Nick does have a separate course, so his YouTube videos are just like a taste of what he actually offers as a course. So you can actually sort of enroll in his courses. And
Well, do you watch YouTube a bit, maybe? Have you heard of this guy called Rick Beato?
yeah, I love
Right?
him. Yeah,
You love
he's
him.
great.
He is great because
He
he's a
is-
music educator. He
Yeah,
plays
he
the
is brilliant.
guitars, but he has his courses as well.
Yeah.
Right. So he started doing this stuff all for free.
Yeah, yeah.
And people are loving it because there's a knowledgeable person speaking about music. Now I'm just an amateur campfire guitarist
Yeah.
and drummer. But I'm sitting there listening to how he takes all these songs apart, and I am literally popcorn. I can sit there for hours.
Yeah.
And how he makes his money is with the course, right?
Yeah,
and
right.
now after 3 million, subscribers,
Yeah,
I'm sure he
yeah.
does quite well out of the
He is just...
But you see my example?
Yeah.
I think there is a model here that will just naturally go there. And whatever people try to do with setting up these micro-credentialing courses and ASAMEM courses and university courses, in
No,
30
that-
years from now, goodbye, it's not happening.
No, they're goodbye right now, I reckon.
Well,
It's
already.
just too, yeah, it's
Absolutely.
just too old-fashioned.
Yeah.
No one's going to pay to be listening to an old fogey like me pointing at the whiteboard,
Yeah.
you know?
Yeah.
Like it's just too old-fashioned.
If somebody from, again, I'm picking on Ghana because I just run into this guy who strikes me as the kind of the example person of who I'm talking about, and he's clearly a young guy who studied something, but not even geology, but he's watching all this stuff and he's clearly educating himself. Right, and if at some point he would come to me and say, "Look, I've watched and I've learned all this material, done all these exercises that they say, can I have a job? Here's an office." Right? You could make
Absolutely.
that. You could make that work.
Oh, yeah.
And you don't need that university degree.
Yeah.
it's-
My way of teaching, I believe, will bring in people completely outside of the geological sphere
Yeah.
to be able to do what I do.
Yeah.
Because what I want to do is transfer my skills that I've learned over the last, 20 plus years to the next generation. That's my aim.
So how are you going to get there? What needs to happen? What's the-
I can tell you, but I have to kill you.
Yeah,
so.
yeah. Well, let's remove all blunt objects here, but I'm not meaning give all the secrets away, but I've got similar ambitions, but not in the structural geology space. But we probably all have little mini circles that are to some
Structural
degree
geology
overlapping, right?
is one of these feared subjects. Mm-hmm. As soon as you mention structural geology in a classroom,
Yeah,
people freak out.
Yeah.
And I don't know why, because they say that certain percentage of the population is 3D blind. And I don't understand that because we live in a 3D world,
Yeah, I think that has some truth to it. I don't understand it necessarily.
I guess
because
I'll find out as soon as I,
Yeah,
release my material and get it tested with people.
yeah,
But first of all, it has to be done in a way that people can understand.
Yeah.
So the traditional way of teaching structural geology isn't the way to go.
Yeah, yeah.
Like that is really...
Interesting.
The other day I met with someone who's had about, 10 years experience
yeah,
and didn't know how to interpret drill hole data. What do you mean by interpreting grade data as structural data? And I showed her an example, a real example. And we spent like 20 minutes on it. She said 20 minutes of that was the most useful thing that she's ever learnt in structural geology, which is crazy to me, but it's something that is completely common sense to me that I use all the time.
yeah. Well, so there's really where you need to focus all your efforts.
Yeah,
So,
absolutely. Yeah, I find it really interesting.
Yeah. So again, I'm sorry, I got way too many questions, but having the same kind of ambitions, having spoken to people with similar ambitions, food needs to go on the table, right? And I find it, so for that reason, I find it really intriguing how people like Rick Beato out of a different industry or people like Nick Tate make the decision to do what they do. And Nick still does his consulting, right? So he probably funds his expedition there with some consulting work.
Yeah.
Is this a similar model there, or?
Well, I have to fund it through my own consulting to build something. Yeah.
Yeah, and the same with Hayden Morton, his geologized content.
Yeah.
There's a lot of people that put a lot of stuff in preaching their particular field of.
Yes.
Interesting.
But it's a new learning method, I think. It's a new teaching method. It's
Yeah.
online. away from the academic sort of sphere.
Yeah.
And we're doing it in a way that's that reaches people. So
But you'll get the haters as well, because already I put a fun post out there that most people completely misunderstood. I said something along the lines of AI is not going to replace geologists. A geologist with access to AI is going to replace
absolutely.
a geologist.
I
right?
agree with that.
But you'll get the people saying, how can you teach geology on the YouTube channel, right? Structural geology, you have to be out in the field, sniff and lick the rocks and all the rest of it. I mean, I'll just put the question out there, but I don't think that's a hurdle, but that's obviously something that...
I know a way.
You know a way. That's good. That's all right. Now you have to kill me. Yeah, I'll switch the cameras off. But no, look, that's really interesting. Maybe before we wrap things up, other than that ambition, what's on your mind right now? I mean, is there anything else that
Well, I mean, the result of the Parker Challenge, that's on my mind.
Yeah.
The fact that the variations are so huge,
Yeah.
plus or minus 200%.
Yeah.
Metal content, is it?
Yeah. I mean,
Yeah,
depends how
and much of that is, a function of the domain volumes.
Yes.
That needs to be addressed, clearly. I mean, that...
But first question, surprised or not surprised?
I'm not surprised at all.
Not surprised.
No, not at all.
Right.
Because we were writing this paper with Ron before. It was in press already, and that's what we basically wrote anyway. So I'm not surprised at all.
Yeah. So you're not surprised. So now what? I mean, Parker Challenge. So you want to talk about that? So what?
We need to have a
now?
way of actually sort of coming up with how to come up with optimal domains, and how to teach people how to come up with.
So okay.
But doing isotropic interpolation is not going to be the way.
Well, but
that's one of the reasons why you have huge variations.
Okay, so part of the solution is the whole education piece. We get that. Is the other unsolvable piece the fact that no single geologist can create an unbiased model?
Is that a hurdle? Sorry.
Yeah. If you would agree with the hypothesis that no single geologist can create an unbiased domain model, then is that the process then we need to fix? And the examples along those lines are, when as a consultant I build a model, it must be peer reviewed from a domaining perspective by an equal or a peer, I guess, before it goes out. And this particular question has been bouncing around for a number of years. Acknowledging the 200% variance, that's where the rubber hits the road.
Yeah.
Wouldn't you then, from a compliance and governance perspective, say, well, okay, you make sure that you have 2 or maybe even 3 opinions for certain deposits of certain size and complexity, whatever you build in there, to get that median or that mean domain. Because, I would say when it's all said, and we kicked this around with the committee endlessly because we didn't have grade control data set for this deposit. And it was a bit of don't want to get in detail of that, but so you could even argue that the mean of those 28 people is still going to be inaccurate, right?
Yeah.
I mean, that's certainly an argument, but it would be a hell of a lot closer than each individual estimate, right?
Sure.
So there is a question wrapped up in that. I mean, do we enforce that on people to try and get more accurate?
Well, there's quicker way of doing it, I feel. So that's what I'm thinking.
Yeah,
about.
but by one single person is what I'm... that's right.
Yeah. To create a variation. Yeah, you can do that.
Right.
I can't tell you. I have to kill you.
Yeah. Well, I mean, this is literally where all of it is heading, right? The Parker Challenge came up with this. We knew this. We've been talking about it for years. Harry Parker's famous quote, Jackie Coombs in her book's famous quotes, et cetera, domaining important. We've now seen it with real numbers. We talk about it. Software companies try to fix it, try to come up. We see it. We know it. What's the solution? I think you either ask more than one geologist every time to come up with a model, because it will never be unbiased if one person creates several versions of the model. That just doesn't float. So you either do that, or you train all these geologists and you provide a higher hurdle for people to sign off on or to create these things who have actually gone through that training that you're talking about, right? Those are, I can see, the only two pathways to get out of this.
For sure, yeah. The reason that Ron and I wrote that paper is that there is a systematic process you can actually go through to determine the geometry of a deposit, axial direction of a deposit. You need to figure that out first. Once you do that, you have actually dramatically narrowed the field down so that you don't create irrelevant models. That's one thing you need to do. But in order for you to do that, you need to have an education. So those two things go together.
They always do, but maybe, because I did want to actually ask that question earlier and I forgot, but in your paper, the data sets that you use, I can see that, right? But how many times do I not get 100 meter space data on my desk that has some limited geological information, probably the lith one that you go out the door, structure, with some gold grades and some something grades, and good luck, give me a model. I can stare at whatever X-ray vision I like. I'm not going to see
You're not
anything.
going to find it. Well, then you have to incorporate that in the model.
You do.
It's very uncertain.
Yeah, that is uncertain. But I think that's one thing when I felt coming out of the paper. I mean, I can see for a lot of the deposits that we briefly talked about before this chat as well. Yeah, look, you can look at it and everybody will probably to some degree see a fold hinge and work it out, right? I mean, well, you said that some people didn't, but you'd have to try hard not to see it. Grade control data is great. I'm always fascinated.
Grade control data is,
I find it fascinating. I get a data set and then they don't give me the grade control data because it's already mined.
That's always happens. Almost always happens.
Almost, yeah. And I said, no, that's exactly not just from a variography perspective to understand grade continuity. Sample support is another matter, but just to see the structure and to see the controls and to then kind of take that concept and project it to whatever poor data spacing I'm dealing with. So, but anyway, it's, I don't know what, anyway, the question was, I get the data sets that you describe in the paper. All I'm trying to say is it doesn't always work that way. I mean, the models I get on my desk, 8 out of 10 times ago.
Yeah, we discuss a very clear case.
Yeah,
that's the whole point of the paper. Just introduce something
the concept,
the concept.
Yeah,
and then we can introduce more complex.
Yeah, what's the most? Have you? I mean, you said before you got some messages and so on. What's the most interesting feedback that you've got on the paper?
Well, just basically supporting. Supporting. Well, I wrote an article on why, I can't remember what it was called now, why a geological model is wrong. That one. A lot of people refer to that when they reach out to me because that means a lot to them. Because they see a lot of models that their colleagues make that just doesn't make any geological sense. Yeah. And that this paper really sort of adds to that message.
Well, it's I put some things out there, and there's always the detractors, and I don't want to focus on the negativity, but I am interested in how you deal with, because you're quite good at not giving a fuck about what you put out there, to put it bluntly, right? And
that's because I don't work for BHP.
No, I admire that, right? And I'm always more careful because some of these discussions I really don't want to wade into at all, right? There's only two sides and both are losing. So I'm really intrigued by your crusading sort of.
It's not so much crusading.
Well, you're really passionate about the opinion. I mean,
I guess I'm passionate about expressing what I want to say, because that's one of the things that people at their deathbeds regret. That's the number one.
Yeah, right.
They said, "I wish I could have said what I really meant to say." Yeah, that sort of thing. I won't have that regret at all.
Yeah, that's interesting. Yeah. So and when didn't you have a different interpretation of some particular geological genesis of some major. I'm probably.
Oh, the VMS you're probably talking about.
Yeah.
There's a lot of syngenetic ideas that are accepted in the.
I'm not familiar with the
sphere.
geology. I completely stayed out of that, but I did have a bucket of popcorn when I read the comments, and obviously people very strongly disagree with that, right?
Yes, very strongly. Yeah.
Does it get to you? I mean, you really just
no, because they're not really arguing they're not countering my arguments,
right?
Because I provide really obvious.
Yeah.
To me, they're structurally really obvious. So that might be a knowledge problem, knowledge barrier. People may not actually be quite familiar with structural geology, but these things are very simple evidence.
Yeah.
And to me, they're just like black and white.
Yeah, right. Yeah.
But they argue based on their emotions. So they're emotionally attached to a certain model. So they would argue, but they're not really making any case at all.
Yeah.
So that doesn't bother me.
Yeah.
Like if someone actually made a case, and I invite people to say, you know, if you don't like my particular ideas, raise a counterpoint. And people have done that. Like there's some people who sent me data and I've examined, you know, the papers and the data.
Yeah.
They're good. I mean, the example that I've been given is very convincing. But there's another explanation as well. So, you know, there's always different ways of explaining data sets.
No, look, there is too, and I think it's, you know, it speaks to your character that you're outspoken about it, because I think particularly online it's so dangerous to say what you think, even though you know you're right. I mean,
you're probably right. Yeah, I'm probably foolish that way, but
well, I don't know. I mean, everybody's exploring it as much, you know, as the other person, right? I mean, it's. Sometimes I wish I'd be a bit more vocal. Sometimes I say stupid stuff, and half an hour later I've deleted it because I think, fuck it, I don't want to get into this. So,
I can understand that.
And so don't see the value of it. But at the same time, and maybe just to close off, using the same responsibility tag again, the more of a following you gather, the more of a responsibility you have to do the right thing, whatever that means, right?
Yeah.
And when I see these YouTubers do their thing, I mean, I'm also deep into chess. There's a Levi Rossman who has got his own channel and is not a grandmaster, but has built his own channel from the start up.
Right, yeah.
I'm fascinated by it. And he's got a responsibility there because he's now got 3 million people listening to what he says about the game, about the ethics, about how these are important things. I think there is... as we've agreed that this is probably the way education is going, if you say something, you need to weigh up a few things sometimes before you click that button. So, interesting.
But it's you know, economic geology to me is really interesting. I find it fascinating that there aren't too many structural geologists in this space. Mm-hmm. Like you can count them on one hand. Structural geology academics, very few people who are actually active in this field. In the field of mining? Involved in mining, but they still work at university. Yeah. There are very few people. Yeah, there are. But the problems, there's so many problems that could be solved. And one of the reasons, I guess economic geology as a subject, as a discipline, split off from structural geology around the 1950s. Mm-hmm. Prior to that, structural geology was really big, you know. But for some reason, when geochemical analysis of rocks became cheap, geochemistry became the dominant force in economic geology, and people have forgotten about structural geology since the 1950s. Yeah. We need to bring that back because structural geology is really the control of, you know, mineral deposits, like chemical alterations of rocks. But people don't look at it that way, and that doesn't make sense to me.
I think it's brilliant, 100% agree. The one job, the one request that we get that I can never fill is a client request for a structural geologist to come and map something. Yeah.
Very few people do it.
Because I can't find these people. I mean, the amount of times that I've emailed the same 5 people, and there's a couple here in New Zealand that are quite famous for it, and they do it all over the world.
That's right. Yeah.
Right, and they're really good at what they do.
That's right.
But they are always busy. right?
Yeah.
And they got to look after their client base, right? And then there's a couple of guys in Australia, and there's a couple of couple of people in Europe.
Yeah, so that's the message, young people.
Yeah, well, I mean,
become a structural geologist.
yes, and the only thing I wanted to do is map rocks, and now kind of to prove my point. I mean, I think I'm an okay mapper, but I just got dragged into all this other. I mean, I never wanted to look at JORC. I mean, what does a structural geo do with JORC, for God's sakes?
That's just admin.
It's governance and admin. But you get dragged into this space. Oh, you're a little bit good at this and this and that. Why don't you go manage a budget and a Gantt chart and tell us how to drill some holes here? And then wait a minute, you wake up 10 years later and said, shit, I was so happy mapping stuff, right? Yeah. But then, try and raise a family when you're away in Africa mapping shit for 6 weeks straight, right? That's not fun.
Well, that you certainly need field experience to become a good structural geologist, and I certainly did that.
Yeah.
But in the field of what I do, like deposit scale analysis, I'm in my room, and doing that through the computer, basically doing structural analysis on computer data, on the data.
No, I agree.
And
you can do both.
That is a great career path as well. And there aren't too many people doing that.
Yeah.
Like I'm one, but there are very few people doing that.
No, I agree, and that should be a call to arms. So maybe that's the right place to finish off today.
Yeah.
But let it be known if people are interested in this, contact you. I'll put a link in there, not with an email address, but they can contact me and if they want to get in touch. But fascinating, man. I could go on for another couple hours, but I think would be boring people about some of our life views. Thanks so much for coming in.
No
man.
worries.
Really
thanks for
appreciate it.
inviting me.
Awesome, man.
Yeah.
Cheers.
Thank you.